This video is on solving other types of equations. Here in our first example, we have 3x to the fourth equal to 27x squared. So to solve, we're going to set one side equal to 0. So we'll subtract 27x squared from both sides of our equation. That'll give us 3x to the fourth minus 27x squared equal to 0. Then we will factor completely. So we have 3x squared. If we pull that out as a GCF, 3x squared times x squared minus 9 equals 0. That x squared minus 9 is a difference of squares that will factor out to give us x plus 3 times x minus 3. So we can set each piece equal to 0 now that we factor completely. 3x squared equals 0, x plus 3, and x minus 3 equals 0 as well. So divide by 3. That will leave me with x squared equals 0. Take the square root of both sides. The square root and the square will cancel, leaving me with x. And then on the right, I have plus or minus square root of 0. So that actually represents two solutions, but it's a repeated value or repeated solution of 0. So we only have to write it one time. But that square root, whenever you're doing the square root of both sides, the square root property kicks in, and then you have the plus or minus square root of the value in which the radical didn't cancel or you weren't solving for. So, and then we have x plus 3 equals 0, which gives us x equal to negative 3 when we subtract 3 from both sides, and then x equal to positive 3 when we add 3 to both sides for our final solution. So we have three solutions here with one repeated solution. And we look back and take note that our highest power of our x value was 4. So we should have looked to have 4 solutions, and we did get those, even though one of them was a repeated value. Next one, we have x cubed plus x squared equal to 4x plus 4. Our highest power of x is 3 this time, so we should look to have 3 solutions. So once again, we set one side equal to 0. In this case, we'll subtract 4x and subtract 4 from both sides, leaving us with x cubed plus x squared minus 4x minus 4 equals 0. Now, whenever you have 4 or more terms and we're trying to factor, most of the time you go trying to factor by grouping. So we group together the first two, x cubed plus x squared, and the second two. Notice I did not separate the minus sign from the 4x. So that's negative 4x minus 4 in the second set of parentheses. So we pull x squared out of the first set, leaving us with x plus 1 in the parentheses. We pull negative 4 out of the second set, leaving us with x plus 1 in the parentheses. If you're factoring by grouping, what's left in the parentheses has to be the same, or you cannot move any further. We do have that. We have x plus 1 in both cases, so we'll pull them both to the front, and then we'll be left with x squared minus 4 in the parentheses. So here we have x squared minus 4, which is the difference of squares once again. That will give us x plus 2 times x minus 2. Now that we factor completely, we can set each piece equal to 0, giving us 3 solutions of x equal to negative 1, x equal to negative 2, and x equal to 2. Solving radical equations. So if necessary, we're going to isolate the radical to one side of the equation. Then we're going to raise each side of the equation to the power of the index of the radical. So in other words, if we have the square root, then we're going to square both sides. If we have the cube root, we're going to cube both sides. If we have the fourth root, we're going to raise both sides to the power of 4, and so on. Step 3, simplify and solve. If the radical still exists, then we're going to repeat steps 1 and 2. And then from there, we'll check. We have to keep in mind that in this process, we have to check because some of our solutions will not work, even if we've done everything correctly. So let's look at the first one. We have the square root of 2x minus 1 plus 2 equal to x. The plus 2 is not under the radical, so the first thing we need to do is remove that 2 from the left side of our equation by subtracting from both sides. That'll give us the square root of 2x minus 1 equal to x minus 2. Now we can square both sides. The square and the square root we cancel on the left, leaving with 2x minus 1. On the right, we have x minus 2 squared, so we will expand that and do our binomial distribution, which will leave us with x squared minus 4x plus 4. From there, we want to set one side equal to 0, subtracting 2x and adding 1 to both sides. That will simplify to x squared minus 6x plus 5, equal to 0. Now we can factor this, and that will be x minus 5 times x minus 1 equals 0. Solving, that will be x equal to 5 and x equal to 1 as our solutions. So, like I mentioned before, we have to go back and check. When we plug in positive 1 into our original equation, we will see we will come down to a false statement of 3 equal to 1. So that means x equal to 1 is not a solution. If we plug in positive 5, it will come down and simplify to 5 equal to 5, which is a true statement. So x equal to 5 is our only solution in this situation. All right, so look at another one. We have the square root of the quantity of 3x plus 1 minus the square root of the quantity of x plus 4 equal to 1. So we want to isolate one of our radicals. Doesn't matter which one we isolate. Just the easiest one to do in this case would be to isolate the 3x plus 1 because we have a negative sitting in front of the other quantity. So we can add both sides the square root of x plus 4. That cancels on the left, and then on the right, leaving us with 1 plus the square root of x plus 4. Now we can square both sides to get rid of the radical that's on the left. They cancel, leaving us with 3x plus 1. And then on the right, we can do our binomial distribution, in which we have 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. 1 times 1 will give us 1. 1 times the square root of x plus 4 is the square root of x plus 4. Square root of x plus 4 times 1 is the square root of x plus 4. And then when we multiply the square root of x plus 4 times the square root of x plus 4, we multiply what's under the radical, and that would just be x plus 4 squared. We don't have to do any distribution at this moment because what's going to happen in the next step is that the square root and that square will cancel out, leaving us with just x plus 4. We can go ahead and combine the like terms as well. The square root of x plus 4 plus the square root of x plus 4 will be 2 square root of x plus 4. Remember, there are numbers sitting in front of your radicals, and that will be 1 in this case. So we have 1 plus 2 square root of x plus 4 plus x plus 4. Combine your like terms of 1 and 4, which will give us 5. And now we can go ahead and isolate the radical that's left. Remember, if you still have a radical involved in your equation, you will repeat steps 1 and 2. So we'll subtract x and subtract 5 from both sides, leaving us with 2x minus 4 equal to 2 square root of x plus 4. Now here, if I wanted to simplify this, I could divide by 2 and divide 2 into each term. But what I wanted to do was just go ahead and square or raise each side to the power of 2. So I can show you what happens if you have to do this. So squaring both sides, notice on this right side, the square times the square root, or the square applied to the square root will cancel, but I also have to square this 2 separately. So that's going to be 4 times x plus 4. And then on the left side, we would do our binomial distribution, 2x minus 4 times 2x minus 4, which would be 4x squared minus 16x plus 16 equal to 4x plus 16. Set one side equal to 0 by subtracting 4x and subtracting 16. That would leave me with 4x squared minus 20x equal to 0. Set each piece or factor completely, that would 4x times x minus 5 equal to 0. Now set each piece equal to 0. So that'll be 4x equal to 0, x minus 5 equal to 0, which gives me a solution of x equal to 0 and x equal to positive 5. Don't forget, we have to check when you plug 0 into your original equation, it will come out to give you negative 1 equal to 1, which is not, which proves it's not a solution. Plug in positive 5 into your original equation will simplify to give you 1 equal to 1, which lets you know that x equal to 5 is your only solution. Here we have another type of equation. We have equations with rational exponents. So if we have a variable, and keep in mind, if we have a term or variable or a number that's raised to a fraction as an exponent, always remember that the numerator is the power and the denominator is the root. So you can, and it doesn't matter which order you actually apply them. So you can have the nth root of a raised to the m power, or the nth root of a to the m power. It doesn't matter which one you apply first. You just have to remember that the numerator is the power, the denominator is the root. So when we go to solving radical equations with the form of x raised to the m over n power, so we're going to isolate our expression with the rational exponent. Then we're going to raise both sides to the power of its of n over m. Its inverse. So once we do that, notice we have 2 different scenarios here. If m is even, in other words, if your numerator is even, we have to bring into account that we're dealing with possibly the square root. So we have to deal with the square root property, or basically an even root property. whenever you have the even root, positive and negative has to come into play. And so we would have two different solutions, in which our solution we would take to, like I said, consider the positive and negative. And if m is odd, if your numerator is odd, we will only have one solution, and we don't have to consider the positive and negative. All right, and then from there we can check. So let's try this out. So here we have 3x raised to the 3/4 power minus 6 equal to 0. So the first thing we do is add 6 to both sides. Then we can divide both sides by 3. That leaves us with x to the 3/4 power equal to 2. The top number is odd, so we're only going to have one solution. So we raise both sides to the power of this inverse. We have 3/4 as the original exponent. So we raise both sides to the power of 4/3. So multiply your exponents here. That would just give you 1 as your exponent. So x to the first power would be equal to 2 raised to the 4/3 power, 4/3 power. That doesn't simplify evenly, so just keep in mind that your program could ask for it as exact, so it could be 2 to the 4th power, 4/3 power, or it could ask you for the approximate answer, so that'll be 2.52. So either or, your answer is fine. Here, in this next one, we have x to the 2/3 power minus 3/4 equal to negative 1/2. So we will add 3/4 to both sides of the equation. Don't forget, whenever you're adding your fraction, you have to have a common denominator. So this negative 1/2 turns into negative 2/4. Add them together, and that will give you 1/4. So this time, our exponent has an even numerator. That means we're going to get two solutions. We're going to raise both sides to the power of 3/2. We're going to invert the 2/3 to 3/2. So this will simplify to just x to the first power. And then here, 1/4 raised to the 3/2. And once again, don't forget, we're going to have that plus or minus, because what we have here in this denominator, the denominator is your root. So that's going to be the square root. And whenever you take the square root of both sides, you have to do that plus or minus, the square root properly. So we're going to do the square root of 1/4 raised to the 3rd power. So the square root of 1/4 is 1/2. And then if you cube 1/2, that's 1/8. So our two solutions would be plus or minus 1/8. Okay, I believe we have one more type of problem that we're dealing with in this video. We have equations in quadratic form. Here we have x to the 4th minus 8x squared minus 9 equal to 0. If we look at x to the 4th, that's x squared squared. And notice in the second term, we have x squared. Whenever we have that type of scenario, that's the quadratic form, the quadratic scenario. If we want to simplify this in order to make it look like something that we've seen before, we can let u be equal to x squared. So that will give us u squared minus 8u minus 9 equal to 0, which is a quadratic equation. We can solve it like we would any other quadratic equation by factoring using, we have u minus 9 times u minus 1 equals 0. That's what that trinomial will factor out to be. We also could use a quadratic formula if we like as well. So here we can solve for 9, solve for u here, u equal to 9, and u equal to 1 would be what we have up to this point. Once you solve for u, don't forget our original equation didn't have u, it had x squared. So we plug x squared back in, x squared equal to 9, x squared equal to 1. Take the square root of both sides. Don't forget, whenever you take the square root of both sides, to solve, you have to have the plus or minus involved. And so that will be x equal to plus or minus 3 and x equal to plus or minus 1 as our 4 solutions. All right, here we have 5x to the 2/3 power plus 11x to the 1/3 power plus 2 equals 0. Once again, we can see our quadratic form here because x to the 2/3 is x to the 1/3 squared. And we also have x to the 1/3 in the second term. So if we let u be equal to x to the 1/3, substitute u in for x to the 1/3 is 5u squared plus 11u plus 2 equals 0. Factor that to 5u plus 1u plus 2 equals 0. Set each piece equal to 0. And if you solve them out, that will be u equal to -1/5 and u equal to -2. So once you solve for u, you go ahead and substitute back in x equal to x to the 1/3. So we have x to the 1/3 equal to -1/5, x to the 1/3 equal to -2. Now to cancel out that 1/3 power, we raise both sides to the third power, and that 1/3 and 3 will cancel out on the variable, leaving us with just x. -1/5 cubed is -1/25, and -2 cubed is -8. All right, so let me know if you have any questions.